Hey Stats class, this is a video showing you how to run a correlation test to determine if you have significant correlation in a data sets using a spreadsheet. So I'm going to put the data in here. For this particular topic, I would actually encourage you, if you have one, to use a TI calculator, because it's a lot easier to get the last parts of this, the p-values and the test statistic and all that stuff. But if you don't have a TI, you can get through it with this. It's just a little bit more tedious than it would be if you had a TI. Alright, so the first thing, it wants to scatter plot. So insert a chart, and then again your scatter chart. I'm going to drag this down so it'll fit in my screen, and I can see this thing is rising as I go left to right. So I can see that A is the choice here. Alright, now it wants, what is the correlation coefficient? I'm going to delete this scatter chart since I got that answered. I'm going to wrap this so it's out of the way. Same thing here. Format, wrap. And then I'm going to put R here. I just label it here and then actually run the correlation here. Equals correlation. C-O-R-R-E-L. The Y is first, then the X is. It's giving me that option. I'm just going to go ahead and hit Tab to accept it and enter. So there's the correlation coefficient to 3 decimal places. That'd be 812. Now here's the thing that you're going to have to do a little work on, that it would be easier if you had the TI. So first of all, these that were set up are always going to be, the row is the population correlation coefficient. So R is for sample. It's kind of like X bar is sample mean and mu is population mean. S is sample standard deviation. Sigma is population standard deviation. Well, the same thing happens with R. R is the correlation coefficient for a population or sample, and rho is the correlation coefficient for a population. So this is the same thing as we've seen with the other statistics and parameters that they estimate. So we're estimating rho using R. So it's always going to be rho equals 0. There is no correlation in the population, and the alternate hypothesis will be it's not 0. There is significant non-zero correlation in the population. All right, the test statistics. So here's where it really comes in to play, the big difference between the calculator and the spreadsheet. For the spreadsheet, you're going to need to know this formula. This is how we get the test statistic from R. But with the other one, you know, with the TI calculator, it will calculate this for you. All right, but I'm going to label it T down here, and then I'm literally writing this. T equals, all right, R, I'm going to click that value for R, divide by SQRT, open parentheses, and then it's all of this in the numerator. So 1 minus R squared. So click that again, shift 6 for the power of 2. So close that parentheses. That's the numerator underneath the square root. Divide by the sample size minus 2, which is the degrees of freedom for correlation test. So there's 1, 2, 3, 4, 5, 6. 6 minus 2 would be 4. All right, then close that parentheses, and there's my value of my test statistic. So they want this typically to 2 places, 2.78. All right, and then finally the p-value. So the p-value is the same thing it has been. This is a t distribution. The t distribution is centered at 0. 2 is way up here. All right, but because we did a not equal test statistic, or sorry, a not equal test, we have to also consider what's down here below, negative 2.78. All right, this is symmetric, so we can just find one and double it. The easiest one to find here is going to be the lower one, 2.7, the negative 2.78, because we're getting ready to use the inverse t, the t inverse, and or sorry, the t-CDF, and that gives you the area below a number when you do the cumulative thing. So I'm going to use the lower number here, the negative version, and double it. So I'm going to label this p-value. So this equals t-dist, t distribution. You can do t.dist or just t-dist. So I'm going to click that one. X is negative 2.78. The degrees of freedom, again, we have 6 here, so 6 minus 2 is 4 degrees of freedom. Don't just do 1 like we did for t-test for means. This is not means anymore. And then cumulative, we want 1 for yes. All right, there's that. We're going to double that, so we're going to do times 2. So there's my p-value. The 3 decimal places is 0.049 the next number would be rounded up, so 0.5. So there's my p-value, and because the p-value is compared to alpha, it's bigger than alpha. It's just like hypothesis test in chapter 8. It's greater than alpha, so there is not sufficient evidence to support the claim. So it's the same conclusion that we make. When the p-value is less than alpha, we reject the null, and we have evidence in favor of the alternate, which here would be that we have non-zero correlation. But here the p-value is greater than alpha, so we don't have evidence that the alternate's true. So we don't reject the null hypothesis. So we say there's no correlation in the population.